Hello everybody, Mikael here, and let's move on with our series in programming in the C language. And today we're going to talk about the basic control flow, how to control what parts of our code is executed. And I have an agenda here, and this is basically the agenda from the chapter 3 in the book, the C programming language that we are following. And we're going to talk a bit about the basic building stones first, like expressions, statements, and blocks. And then we're going to see the if-else statement and how it compares to the switch case statement. We're going to look at the three types of loops: while, do while, for. And we're also going to check out the Goto label just to know what it is. So let's hang on here. The control flow is basically to specify in which order the computations should be done. So we have these basic structure statements that will help us do that. And these are in general the same for any type of language that resides in the same family of programming languages like C does. So if you are familiar with another language, I'm most certain that you sort of can relate to the structure used here in C. So if we start here, we have expression statements and block of statements. So the expressions first on top there are small bits and pieces of parts of calculations that always return a value. So up here they might be returning a true or a false value, or 0 or 1, that is, but they can also return other types of values, like assignment operator could return any value. But small bits and pieces returning a value. A statement, that is a complete statement that ends with a semicolon. So here we have assignment statement, incrementing, calling a printf. These are all statements ending with a semicolon. And then we can organize statements into this block of statements. So we're having the block parentheses here. And we see this usually when we organize code in functions, if statements, switch, or loop statements. So let's start with the if-else. So this is typically a decision point for the language. We have an expression there. So if this expression evaluates to true, then do this block of statements. Otherwise, else, do this block of statements. So it basically turn left or turn right and do this based on one expression. In C, we can omit the block. So we don't need this block parenthesis when we only have a single statement. So we could write like this. So if expression increment A, else increment B, and C will always be incremented since that is outside of the sort of if-else statement. However, it's maybe not that always that good to do like this, since it can turn into a sort of a troublesome part where you can sort of need to troubleshoot. And the reason is, when you have this kind of construct and then you, for some reason, you think you want that C increment should also be a part of the if expression, and maybe you sort of forget that you don't have the block statement there, the whole block parenthesis, so you will eventually get an error, or even worse, you think that two expressions are executed, but you forgot the block parenthesis and only one statement is executed, and that can be a bit troublesome to actually sort of troubleshoot at the end. So my suggestion is to good visualizing the code, what is actually happening, I suggest you use block statements, my personal point of view. So here we have an else if expression. So this is if this expression is true, then do these statements. Otherwise, if this expression is true, then do these statements. Else if this expression is true, and at the bottom, else do these statements. So This is a 1, 2, 3, 4 type of decision point based on different expressions, and only one block of code will be executed here, and one of these will for sure be executed. Okay. A switch case statement is a, well, let's call it it's a specific if-else statement, basically. It's particularly good, or it's used in general when we only having one expression, and this expression can evaluate to different values, and we want to check what value it was and do different things about it. So we have one expression, and then we have case this value, case that value, case another value, and at first match of the value, then the statements will be sort of executed. And then we can break out from the switch. So when we are done with a specific case value, we done the statements, we can do a break to move out from the whole and stop continuing to execute, check more values and do more statements. At the bottom, we can also have a default statement, and when none of the values above was matched, or we didn't have a break statement, then the default statement will always be executed at the bottom. So this is a food for thought. If you only can select between the if or the switch statement, which one would you use to create a program like this? The program in general is it's getting an argument from the command line, a value, and it's checking if it's matching a month. So 1 is matching January, 3 is matching March, and 14 is matching no, for we don't have such a month. So what would you use here? Since we only have one expression that can have many values, this seems to be a good place to use the switch statement. So that's what I'm going to go for if the if/switch was my only choices. So here we have another one. What would you use then? This is a defining a leap year, and it looks like we have several different rules to find out if this is a leap year or not. And what would you do if you only could use an if or a switch statement here? Well, I would say that it seems a bit hard to use a switch. Maybe I could do it with a switch, but it seems that we have different type of expressions. Looks a bit more like an if statement should go here. Different type of expressions giving different values. Yeah, I would go with an if statement here. If this were my only two choices, if and switch. I do remember that we have seen a calculation of this leap year done in one simple expression, and I do think I could do that, and that would be a more better option to solve it in that way, I guess. But yes, okay. Let's move into the loop areas, and we start with the while loop, where is a we have this while and we have the expression, and as long as this expression is true, we just go around, and we execute all the statements as long as the expression is true. So this typical type of loop, eventually it usually ends when the expression sort of gives the 0 value, and then it stops from sort of executing. And as the same thing with the if-else statements, here we can omit the block parentheses if we want to, but then only one statement will be executed. And like I said, it might confuse the reading the code, what is actually done here and not, or is it one or two statement that is actually executed within this while. So I'm taking that side and sort of suggesting do not omit sort of the block parentheses. They do help in viewing and keeping the structure of the code. So that's my point of view. This is the for loop, and it has a different kind of setup. So we have a for loop, and we have 1, 2, 3 expressions, and then we have the block of statements that is sort of executed for each sort of loop around. And the first expression here, that is usually used to initiate some kind of loop variables or loop counter variables there. So that is only executed once at the first time when entering the loop. Then we have expression 2. That is always executed before each loop entry. So that is mostly used to have some kind of expression that sort of say, okay, do one more round. Now it's done. So when expression 2 evaluates to false, then we are done with this loop setup. Expression 3 is always executed after each loop round. So it's executed before entering another loop round. So here we basically try to sort of increment or decrement a loop counter, and sort of this is a good loop construct to sort of go around this loop a certain amount of sort of times that I can increment or decrement. That is good for this. So we see here at the bottom then we have the first part there is the initiating part. Then the second one is the condition. Do this loop while this condition is true. And then we can have the last part here where we increment or decrement the loop variables. We can have infinite loops if we want to. Could be good or fun, but we then should use some other way to sort of break out of the loops. And if you remember this break command that we saw in the switch case statement, that could be used to break out of the loop. So maybe if you sort of within the statements here in each loop, you have some kind of if statement, then you can also have a break, and that will break out of the loop. But these two are then examples of infinite loops. You in general can use any loop constructs to sort of create the loop you want to. So for while, well, let's see the last loop also. This is just the typical loops, the for loop, int I equals 0. So we define the variables there, and then we have this sort of check this value as long as I is less than 10, then do this loops, and then we increment I on the next. So we will for sure then get like 10 rounds in these loops perhaps. The other while here, the other loop here is the while loop, and this seems to be like trying to calculate how long a string is. So this is an assignment, assigning perhaps the value of the sort of the value of the string to the character for each loop. So maybe this could sort of be a trying to calculate the length of a string, perhaps or something like that. At least this is the while construct that as long as this character assignment of the string plus plus is providing a value that is not 0, well, then it will sort of move on and continue. And as soon as it gives a 0 value, then it will sort of remove itself from the loop construct. We also have a do while loop, and the thing with this loop is that it will always enter the first statement. So it will always enter the block at least once. And then at the end, the expression is checked. And if this expression is true, well, then it will do another loop round. So all of these free loops can, I would say that you can, in general, use any of these loop constructs to do what you want, how you want to set it up, your loop. But they have some characteristics. So the for loop is very good when you increment, so you know how many loop rounds you're going to do. You're using a loop counter. Good. The while loop, you don't know how many loop rounds you're going to do, but you have one expression that will for sure know when you are done. And do while will be the same, but then you want to ensure that at least one round I want to go in here. Oh. And it's usually best to select the loop construct that is sort of most obvious for this sort of the type, the particular algorithm you're trying to solve at the time being. You can nest loops, you can nest if statements, and you can nest them to any level, and that is fine. In general, you want to try to avoid nesting too much because it provides you with a bit of complexity of the code. It's good if you could sort of rewrite the code and be it more sort of plain without having this intending the code. But the nesting loops, fine, works on any loops and combination of loops or combination of if statements and switch cases, just to show off how this nesting works like. Then we have this break and continue. We talked a bit about break. And this leaves, when we enter a break, we are leaving the current loop or the switch blocks. We jumps out from there. We say done, enough, break out from this. Continue works in a similar way, but it says continue is like move to the end of this loop construct and do the next loop round. So it's a way of sort of perhaps checking an expression at the top and say, no, I don't want to calculate this. So just go to the next round in the loop. So then I use continue to do that. So continue and break, two items that will help us sort of specialize our loop constructs. And then we have the Goto. And it is in general suggested we shouldn't use Goto. If you create program using a lot of Gotos, it could sort of end up being a mess. It's hard to read code that use Goto. And so let's just say we try to avoid it. Maybe in some circumstance you really must use it, but still try to rewrite the code, try to avoid it. It's not sort of thought as good practice to use Goto and label, so we recommend to avoid it. Here is an example of where we are using Goto and label. So this is a sort of nested loop on 3 levels, and let's say that something bad happening in the inner loop there, and there is really no way that we could sort of leave this loop with a break statement and so just for the purpose of having an example for Goto and label, here we are having Goto error, and the label down there is the error label, and then we sort of can clean up the mess, just to showing how it can be done. But still, try to avoid it. In general, it might not be that necessary to have these constructs then. So there we can sum it all up. This was about the control flow. We talked about expressions, statements, and blocks. We saw the different constructs, how we can do the if else, and we discussed how switch case relates to this. And we saw examples on them. Then we talked a bit about the free loop constructs, while, for, do while, and their characteristics. And then we talked about Goto label. And this basically sums up all the control flow that we have here in the C programming languages, and just to steer the basic control flow. And that will be enough for today. And still we need to write example programs to practice and sort of use what we now have learned. So go home, code, practice, and I will see you in another session not too far from here. Okay? Have a nice one. Bye bye.